All right, guys, for really lack of a better way of putting it, I call this problem solving with means. And it probably would be more appropriate to, trying to get a blank sheet of paper here. I want to show you guys some stuff. It'd probably be more appropriate to just call it weighted means. And let me explain a little bit about what's going to happen here. When we start out with just the very simple sample mean formula, we know that we add up our scores and we divide by how many scores that we have. And because n can't be 0, it'd be kind of silly to think that we'd find the mean of nothing, no scores. We can multiply both sides by n. So these things cancel out, as you guys like to say. So on the left-hand side, we get n times x bar is sigma x. Now, at the end of the day, what we're saying is we can find the sum of our scores. Well, pretend that's a C. By taking our sample size times our mean. Okay. So if I have a class of 30 students and I know that their mean was 80 on the first exam, then maybe I don't have the scores, but I know that the sum of the scores would have to be n times the mean, which is 80, which is 2,400. If I add up all of the scores for 30 students with a mean of 80, it has to be 240. And it should make sense because the only way I can get a mean of 80 is to take the sum of the scores divided by 30, which gives me the average of 80. So we're going to use this in some crazy ways. Well, not really crazy ways, but I think it's things that any person taking an introductory statistics class should know how to do. So the first problem says a professor has a 9 a.m. statistics course and reported a mean score of 70 with 15 students. So the 9 a.m. has a mean score of 70, and she had a small class with only 15 students. She reports a 1 p.m. class had a mean of 82, and 32 students. Apparently, what she'd like to know is for all of her students, all 47 of them. You know, again, combining. Maybe she did the same instructional technique for both classes, and it was the same exam. And she wants to see how all the scores, or I'm sorry, all the students scored. So, what would be the average for both classes combined? Now, totally incorrect. But often used would be to take the 70 plus 82 divided by 2 and say that the mean is 76. That would be true. That would be the correct way to do if both classes, for example, had 15 students, or both classes had 32 students, or both classes had 40 students. Doesn't matter. If the sample size, if the number of students in each class was the same, then you can take the 70 and 82 and add them together and divide by 2. But guys, when you get into a situation where you've got more students that contributed to one score than contributed to the other score, that's not the way it works. For example, what if I have the following numbers? Well, the average of my first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is 1. The average of the other is 10. There's no person that has any reasonable quantitative literacy to them that thinks that we should be able to add that 10 and that 1 divided by 2 and get 5.5. and that be the average of these numbers. These numbers right here are going to weight more because there's more of them. They're going to have more weight, so we have to figure that into the calculation process. So, guys, ultimately what we're going to do is we're going to find the sum of each set of scores. So remember, we find the scores, the sum of the scores, by taking n times the mean. So I'm going to take 15 times 70. Calculator's messing up here. So the sum of those scores had to be 1,050. The sum of the scores for the 1 p.m. is going to take 32 times 82. Is 2624. If I add these two classes together, the total of their scores has to be 3674, 1,050 plus 2624. So I can find my new mean by taking the sum of the scores for everybody divided by the sample size for everyone. Remember, 15 students in the first class, 32 in the second, makes 47 total students. And I can get an average of 78.17. Okay, easy stuff if you know what you're doing. So if you think about the mean of 70 for the, get this up there where you can see it, for the 9 a.m. and the range of those scores out to 82 for the 1 p.m., smack dab in the center of that is the 76. And that would be the mean if these two weighted equally. But this 82 has more weight because there's more scores that created it. Therefore, our mean is going to be pulled toward the value, the mean, that has the most weight. So it's pulled from the 76 toward the 82 because there was more of these. There was less of these. This 70 had less weight. All right, number 2. A professor has 5 students in a physics class. Let me get this straight where you don't have a crick in your neck. The mean for the first exam was 82. All right, gang, what do I know right off the bat? I know that if this person had 5 students and a mean of 82, that the sum of all scores for the 5 students had to be 410. But the professor forgot to record one of the exam scores. If the other 4 exam scores are recorded as this, what's the missing score? Well, guys, I'm going to subtract out the 78 that I know. And I'm going to subtract out the 65 that I know. And subtract out the 88 that I know. And we don't need subtract, do we? That would be weird. And subtract out the 89 that I know. Well, guys, the difference has to be the missing score. There's no other way it could be anything but a 90. All right, gang, number 3. A professor tells his students that the final exam will be canceled if the average on the midterm is 80 or higher. On the day of the exam, only 31 of the 32 students showed up to take the exam, and their average was 79. So, gang, for the 79 students, I'm sorry, for the 31 students who had an average of 79, the sum of their scores was 2449. Now, the only way the professor is going to cancel the final exam is if all 32 students average higher, 80 or higher. So they've got to come up with a total of 2,560 points for 32 students to have an average of 80. Well, what's the student got to have? Well, they've got to bring the the total sum that they've got up to the 2,560 once this person's score is calculated in there. So this person's going to have to get a score of 111. So that's kind of a good situation to be in if you're that 32nd student, because what you could say is, well, it's a 100-point test, assuming it is. Now, there's no way I can get 111, so you guys messed it up before I even got here. So what would be bad is if the score is like a 90 and this person had to get a 90 or higher for the final exam to be canceled. So no, that would be a lot of pressure. So guys, this student would have to score 111 111 for the final exam to be canceled. You got to wonder if it's 80, if it's 79.5, which rounds up to an 80, if the professor would do that. Let's see if that changes anything. Let's go 79.5 times the 32. So you would need 16 points. So 2544 is what they would need. And the first 31 students got a 2449. So according to that, if the professor is willing to round any 79.5 up to 80, like we typically do, might be a strong argument for 95 or higher. Now that would be some pressure. All right, number 4, provided is a histogram of exam scores for students from a large statistics class. What is the median score? Well, it looks like one student scored a 0. So I'll tell you what I'm going to do. I'm going to create a frequency distribution over here. And look, this probably was an AP test because AP scores run from 0 to 5. So we got 0 and 1, 2, 3, 4, 5. And it looks like one student scored a 0 and one student scored a 1 and 5 students scored a 2. And it looks like 8 students scored a 3. And it looks like 15 students scored a 4. And 25 students scored a 5. Now I can't imagine that being an AP test because those things are hard, and you're not going to have, I don't think you'd have that many 4s and 5s. But so first of all, how many students do we have? Well, we got 1 and 1 and 5 and 8 and 15 and 25. So we have 55 total students. Now the median is going to be, with these things arranged from low to high, it's going to be the middle score. So if I take 55 divided by 2, when these things are arranged from high to low, the median is going to be about the 27th or 28th student. Well, if I do a cumulative frequency, which we talked about before, we could go 1 and 2, and add our 5 is 7, and 8 is 15, and add our 15 is 30, and add our 25, which gives us 55. So we're trying to figure out, where does that 27.5, 28th student fall? Well, the first 15 students have scores 3, 2, 1, 0. The 16th, 17th, 18th, 19th, 20th, 21, all the way up to 30 have scores of 4. So guys, the 27th, 28th student would have to fall right in there. So guys, the median would have to be equal to a 4. Now, I didn't ask this, but what's the mean score? How would you calculate this if you wanted to know the mean score? Well, guys, I'd use the frequency distribution that we used before. I would, or just do the sum of the scores. I mean, you could do that. You could say, well, The sum of the scores for the one person who had a 0, 0. The sum of the scores for the one person who had a 1 was 1. The sum of the scores for the 5 people who had a 2 was 10. The sum of the scores for the 8 students who had a 3 was 24. The 15 students who had a 4, their scores would sum up to 60. And the 25 students who had a 5, I'm just going to put 25 times 5. I know it's 125. So some of the scores would have to be 220. And I have 55 students, so the average would also be 4. Now, you could use a frequency distribution, go clear enter, and go up to L2 and go clear enter. And I could go 0, 1, 2, 3, 4, and 5. And then put in the frequencies 1, 1, 5, 8, 15, 25. And then I could go stat, calc, one variable stats, and do L1, comma, L2. And that's the way we handle frequency distributions. So either way, and that's kind of weird. That's one of those weird situations where you end up with a mean of, and it's the reason I put this on here, you end up with a mean of 4 and a median of 4 in a positively skewed distribution. And that contradicts what I taught you in the previous video. Because you would think here, you would think because of the skewed distribution that the mean would be less than the median. And if you go back and rewatch the video, I was very, very careful to tell you that this is true in most cases. But there are some kind of strange cases, and it took me a while to figure this out, to create this, that would create that situation. But guys, anyway, good stuff, I think. I'll tell you one that a question that I gave on a test not long ago. It was something like this. A basketball player has played in 9 games and is averaging 11 points per game. How many points would he or she, whatever is going on here, need to score in her next game to raise their average by 1 point per game? So, what do you think? Wow. All right, so what do you think? Sorry, I was reading a text. All right, so guys, go do the same thing. I'm going to work with sums. What they've got, and I'm going to compare that to what they need. The sum of the scores currently after the 9 games would be how many games they played times their average. So they currently have scored 99 points. If they're going to raise their average by 1 point per game, then their sum after 10 games, if they raise this by 1 point, it's going to be 12. They have to have 120 points to raise their average by 1 point after the next game. So I can take the total that they need minus what they got and tell you that this basketball player is going to have a pretty decent game. Going to have to score 21 points in their next game to end up after 10 games with an average of 1 point per game higher than what they started the game with. So guys, I don't know if that'll show up on your first exam. It's very likely. I don't know. I'll tell you what I want to do. I want to have some fun. All right. I have a song I want you guys to listen to. I consider it to be, well, here you go.
I stay out too late. Got nothing in my brain. That's what people say. That's what people say. I go on too many dates, but I can't make them stay. At least that's what people say. That's what people say. But I keep crazy.
Okay, I can't shut Taylor Swift up here. I've been trying to turn that off for like the last minute or so. Here's what I want you to do. I don't know if you guys ever saw the video. There's a police officer that was singing that. It's actually pretty entertaining. And actually my buddy did a video. He was trying to teach his daughter to drive, and he was singing that to her, trying to mess with her. They were on a farm. It wasn't like they were out on an interstate or anything, but he was trying to distract her by singing that. It's actually pretty good. I tried to get him to put it on YouTube. Anyway, I think we all could think that's kind of an annoying song. So here's what I want you to do. Let me get a sheet of paper here so we'll all know what's going to happen. I kind of want to know who's watching the videos and who's not. So here's what I want you to do. If within 6 days of this video being posted, I cannot shut Taylor Swift up. There we go. So of 6 days after this video being posted, and I'm creating it today, and it's going to be posted tomorrow, but I don't want to give a date because I may use this video in upcoming semesters. So 6 days after with this video being posted, if you will send an email to me at ddarbro@shawnee.edu, and in the subject line put quiz number 1, and then in the body tell me my most annoying song is. Tell me what it is. I'll give you 25 points out of 25 on quiz number 1. So all you got to do is just have watched the video to this point, send me a quick email, subject line quiz number 1. Now I'll tell you what, do quiz number 1 1500, because I'm teaching some other classes. So quiz number 1 1500, and tell me your most annoying song, and I will give you 25 out of 25. Those of you that don't send it, you'll get 0 out of 25. So it's a real academically generated quiz here. So guys, have a good one. I'm done.